Question 37 is part of this group of questions from 35 through 37, which we had read the prompt for in question 35. And question 37 says that Mr. and Mrs. Smith plan to roof the cabin on 2 consecutive days. Assuming that the chance of rain is independent of the day, what is the probability that it will rain both days? And as answers, we have decimals from 0.04 to 0.40, and we also have a pattern of doubling between A, B, and C, as well as between D and E. As far as the ACT math concepts from reading the question, what we're dealing with is probability, and specifically it's the probability of independent events happening. And the part of the prompt that is going to be relevant to this question is just this last sentence here, that during the week the Smiths plan to roof the cabin, there is a 20% chance of rain each day. As far as solving this question, essentially it comes down to knowing how to find the probability of independent events. So I'll write that out over here. Approaches: 1, formal, use knowledge of probabilities. And it's a very quick question if we know that. And then I'm going to write another way, which is that if we don't know how to do probabilities, we could still reason through it with a small real-world example to reason through the question. To solve it using probabilities, I'm going to first write out what we actually need to know as far as probabilities go. So probability of 2 independent events. To find the probability of 2 independent events that occur in sequence, find the probability of each event occurring separately, and then multiply the probabilities. So this is occasionally tested on the ACT as it is being tested right here. The way we're going to use this on this question is that we're trying to figure out the probability that it's going to rain on 2 different days, each of which is independent of the other. And there's a 20% chance of rain each day. So to calculate the probability that it's going to rain on both days, we're just going to do 20% times 20. And that will be our answer. I'll pull up the calculator here. So 20%, we can make that into a decimal as 0.20 and then times 0.20. And that gives us 0.04. So A is our answer. As I mentioned earlier, this question is super quick if we're familiar with how to calculate these independent probabilities. But it's not uncommon for test takers to be either rusty with this sort of calculation or just to be unfamiliar with it in the first place. And if that's the case, we could still reason our way through this type of question by using the second approach, which I'll talk about now. So the idea is we can just think of an everyday situation that involves some sort of independent probability and try to figure out how the math works in that situation and then apply it back to this particular situation. For example, we could use the idea of flipping coins. If we flip coins, we might ask ourselves, well, what is the chance that we might get 2 of the same side in a row? For example, getting 2 heads in a row. Well, we know that there is a 1/2 chance that we get it on the first flip. And we also know that the probability that we get it on the second flip is not going to be affected by the outcome of the first. So there's also going to be a 1/2 chance of a heads on a second flip. And what we might do now is actually list out the different options that could happen on any 2 given flips. So we could get 2 heads, we could get a heads and a tail, we could get a tail and a head, and then we could also get 2 tails. And these are the only possible outcomes we could get on 2 coin flips. And what we can see in this little example is that for any given combination, there's only a 1 in 4 chance that we'll get any particular one of them, since there are 4 possible combinations and they're all equally likely to occur. And then we can ask ourselves, well, if there's a 1/2 chance here of getting a heads and then a 1/2 chance here of getting heads there, what is the actual math that will result in a 1/4 chance of them both happening? And we might deduce that it's actually multiplication between these two, that we're multiplying the probability of an individual event. And when we do that over the course of multiple events, we get the probability that they all happen together. And we could apply that back here and then do the 20% times the 20% like we did this first way, assuming that we had that formal knowledge. Let's take a look now at some of these wrong answers. Answer choice E of 0.40 could reflect the mistake of adding the probabilities of each event rather than multiplying them. And then answer choice D of 0.20 could reflect the mistake of just assuming that the probability of both events happening is going to be the same as the probability of either one of them happening. And from a common sense perspective, answer choices D and E don't really make sense. For example, if there's a 20% chance of rain on one day and then 20% chance on another, the chance it's going to rain on both days isn't going to go up or stay the same relative to just one day. And then answer choice C of point 16 could reflect finding the probability that it will not rain on one of the days and then multiplying that by the probability that it will rain on one of the other days. If you do 0.8 times 0.2, we get 0.16. And then for answer choice B of 0.08, I'm not sure what they were anticipating with that answer, although it might be related to it being the double of A. All right, and then I'm going to write out what we ultimately needed to know on this question. And as we saw, it just came down to knowing independent probabilities. Needed to know how to find the probability of independent events. As far as ultimate takeaways on this question, one is the fact that just like questions 35 and 36, the majority of the information from the prompt was not even relevant to solving question 37. We only needed to use this one sentence. And I talk about why that is more in a video that summarizes all of 35 through 37. So check that out once you've finished with this. Another takeaway is that it is good to be able to find the probabilities of independent events. And also, in general, if we're unfamiliar with a formal math approach, being able to give ourselves small examples and try to deduce the actual math behind it can be a helpful tool that every once in a while comes in handy, as it could for this question. That wraps things up for question 37. Let's take a look at 38.